So what is data warehouse looks like in a technical point of view? Let us continue study this. A data warehouse is based on a multi-dimensional data model, which views the data in the form of a data cube. Let's look into a data cube and then discuss the multi-dimensional idea. So a data cube, such as cells, allow data to be modeled and viewed in multiple dimensions. Saying that we looked into a three-dimensional data cube. Again, we are like managers in all electronics, and we want to create a sales data warehouse with the following three dimensions. We have time dimension, we have item dimension, and we have location dimension. So saying that we use those three things putting together, we are able to create a data cube looks like this. And of course, if you try to read the information behind it, you can understand that, say, 927 is a combination in the dimension of home entertainment with Q4 sales in Vancouver. So that you can see this is a three-dimensional data cube that put their sales information in terms of three different ideas, including the locations, and locations can be subdivided into Vancouver, Toronto, New York, Chicago. Time can be separated into Q1 through Q4, and the items can have multiple types that we stored inside of the data cube. Each dimension can easily expand or condensed so that we can get more detailed information if we want. In other words, the time, what we see over here is Q1 through Q4. It should be able to easily divide it into months, even weeks. And you can, of course, condense into the year to see the different informations in there. The locations is the same thing. You can separate that into country, you can divide into city, and you can probably go even further into county or some zip code kind of idea, as long as your design supports those ideas. So this is a perfect example for a data cube to look like in a three-dimensional data cube. Now, think about this. We mentioned this can be a multi-dimensional data warehouse concept. So a data cube such as cells allow data to be modeled and viewed in multiple dimensions. And think about this before I move into the next slide. Look in here. Suppose that we want to do all in electronics, create a sales data warehouse with the same three dimensions, and now I want to add an additional dimension, supplier. So now we have a four-dimensional data cube. So before I move into the next slide, think about what is this looks like. What is a four-dimensional data cube looks like? Try to picture that in your mind, and we, of course, is going to move on to the next slide and show you what it looks like. So this is what it looks like for a four-dimensional data cube. It still contains all three dimensions in each cube that you have. You can see that because we have three suppliers, we will be able to add those three data cubes together to form a four-dimensional data cube. And therefore, you will be easily to extract as well as expand all the information that you want to see in terms of the data in here. And this can be very helpful for us to move on to the next stage of the data mining process, which means that we can really apply the programs into the data that has been well managed so that we can extract information easily. And of course, a five-dimensional data cube would be additional layers of the information that we see over there. So saying I want to add a fifth dimension with two possible values, then what you will see is that you will have two four-dimensional data cubes that I showed in the previous slide, putting them together forming like six data cubes, and that is the idea of the five-dimensional data cube would looks like if we really want to present that in a visualized performance here. Of course, in computer, we don't really need to show those informations. All we need to do is find our way to read those files, and then we can write a program to process those information. So conceptual model of the data warehouse. The most popular data model for the data warehouse is the multidimensional model. And how do we describe the model? How do we write the code to define a data warehouse? This is what we want to see. We can see some simple code to understand how do we construct the data warehouse. The model has three basic formats of it. The most basic one is called a star schema. The next level is called snowflake schema, and the final one is called fact constellation schema. So starting with the star schema, which is like the most basic format of the data warehouse. For star schema, it's a fact table. So we focus on one fact table. Like we see previously, we have sale as our fact table. Now we want to look into the sales information. So a fact table is in the middle of the connected to a set of the dimensions tables. So not only you want to define your fact table, you also want to define your dimensions. And it contains a large central table as well as a set of smaller attendant tables, one for each dimension. So what it would look like is going to be similar like this one. You can see that we have in the center, we have our sales fact table. In here, it has 4 dimensions. What you can see is time, item, branch, as well as location. Each one of that has their dimension definition. So you can define the dimension table over here in terms of the time. You can have the key. You can define the day of the week, so that because you define day of the week, you can have weekly information to be able to be retrieved. You have month, quarter, and year in the time dimension. In branch-wise, you can have branch key, branch name, and branch type to define different branches. Item-wise, it's going to be similar. Item key, item name, brand type, supplier type. For the location, you can have location key, street, city, province or the state, as well as the country. And of course, by looking into defining this way, you can separate your data in terms of the city, in terms of the state, in terms of the country. So this is what the code looks like in the data warehouse code. Of course, data warehouse, the topic itself can be one semester long class. In here, since it's only one smaller component of the data mining process, this is some code that I found in the OLAP processing. So I want to give you guys a flavor about what a data warehouse looks like. So starting defining the data cube as we see, and you can see define cube is like the reserved word in here. We want to set up our dimensions. So you can have sales, star, time, item, branch, as well as location. So those are the 4 dimensions you define. For every single dimension you define here, you also need to define their dimensions in define dimension reserved word with the name of that as well as all of their attributes that we want to find it. Of course, besides the dimension you have defined, you also want to have the dollar sold equal to the sales in the dollar unit, so equals to count star, and therefore you will be able to create a structure that we have seen for the most basic form of the data warehouse. And of course, you can see there's many different, many reserved word or many style that we use in database. So there is some similarities, and of course, there are some different focuses as we mentioned in the previous video. Snowflake schema is actually a little bit deeper into our star schema. For snowflake schema is a refinement of the star schema where some dimension hierarchy is further splitting. So it can create more layers in the dimensions into a set of smaller dimension tables, forming a shape similar to a snowflake. However, the snowflake structure can reduce the effectiveness of browsing since more join will be needed. And of course, you would understand this part when you learn about the database. And therefore, you can see that in this case, the regular data warehouse structure is here, but now in Snowflake schema, we added 2 additional tables on the item dimension as well as the location dimension to get more detailed information. And you can see that for a supplier, we create a supplier key as well as the supplier type to add 1 more dimension out of the item dimension. The same thing about the city. The original location has been subdivided into city information, and now we have additional tables over here in the city concept. And in this case, we are creating what we call a Snowflake schema to get more detailed information in the dimension, in 2 dimensions that we already defined. And of course, by looking into the code, that is not that difficult to define. When you define the dimension inside of the dimension, you simply add more information. When you put a supplier, originally it's just an attribute, but now we put a parenthesis over there to define the further dimensions of each one so that we can define a dimension inside of another dimension. And it's the same thing about the location here. So this is the idea about what a data warehouse code would look like. The final one I want to introduce to you guys in the data warehouse schema is the fact constellation. So this indicates that when you have more than 1 fact table, sometimes sales is an important thing, but there's also other things that you want to focus on, such as like expanding or the cost, etc. And therefore, if we want to put those say 2 important fact tables at the same time, while some of the dimensions they can share and some of dimensions that they really look into individual ones, and that we will form what we call a fact constellation. So therefore, this is sometimes also called a galaxy schema or the fact constellation to be the name or the style of what we are looking at. Again, this is the type of the schema that has more than 1 fact table. So you can see in this one, in this example, we have sales as the fact table, we have shipping as another fact table. And now we have several dimensions that are shared by those 2 fact tables, such as the time. You can see the time has the time key connected with the sales fact table as well as the shipping fact table. Item is the same thing. They have been connected with each other. The location is the same thing. They use the same thing to find the locations connected with each other. Branch dimension table is only attached to the sales operation. So some of the dimensions are shared and some of the dimensions are individual. And this is what we call a fact constellation as the last schema that I want to introduce to you guys in the data warehouse concept. So concept hierarchy. One important thing about the data warehouse is about the dimensions. And each dimension, as you can see, they have some hierarchies inside of the dimension. So concept hierarchy defines a sequence of mapping from a set of low-level concepts to a high-level concept. Consider a concept hierarchy for the dimension called location. So location-wise, you can look into city, province, country, and you can have all. It's also possible to go deeper, saying that it's a big city, you have multiple zip codes in there. You can further divide into like streets, etc. Depends on how you define when you creating your dimensions. You will be able to define how deep that you want to go in the hierarchy levels. So many concept hierarchy are implicit with the database. So street, city, state, country, etc. They are pretty well defined in the mind. However, there's also sometimes they are not really linear. For example, like time. You can go this way, month, quarter, and year. You can also go week. So that they have different routes to create their concepts, and how would you want to define it is also pretty interesting design problems in the data warehouse structures. Concept hierarchy can also define by grouping values for a given dimension or attribute. So you can really literally go in there and then hand define those hierarchies over there. So for example, money. Money is not really having some real boundary separation. Of course, you can use the number of digits to look into that. But in this case, we can really using like all the items between $0 to $200 are considered lower priced items, and you can separate those things into 5 levels, and each level can be further divided into multiple levels, so you can easily define the hierarchies inside of the data warehouse. So how are the concept hierarchies useful in OLAP, in data warehouse? It is in the multidimensional model. Data are organized into multiple dimensions, and each dimension contains multiple levels of abstraction defined by concept hierarchies. So the idea is this: you can, once you have your data cube, you can do many different operations, and all of these, one important thing about data warehouse is that all of these are pre-calculated. So it's not really using a real-time calculations. When you want to, what we call the roll up, so you can see that when we try to roll up over here, we actually merging by compare these two data cube. You can see that they roll up in the location concept, make it become USA as well as Canada. Because all of these data are well stored in the data warehouse. When you want to roll up, the data warehouse do not need to take time to calculate. You need to understand sometimes this data is like multiple terabytes or even petabytes. Because all of those are pre-calculated, you can get all those information like immediately so that you can play with your data warehouse information. So you can do the roll up, you can do the drill down. So originally it's 4 quarters. Now I can easily separate that into different months. We can do another operation called dice. So get a smaller cube. So in this case, I only interested in Canada cities sales in Q1 and Q2, focusing on home entertainment as well as the computer. So we can get this cube over here quickly. We can get a slice of it and we can rotate the locations. So these are the basic important operations that are doable in data warehouse, and you can see how easy it is that provide the information to the decision makers. Like we see, the rolled up is going to be summarized the data by climbing up hierarchy or by dimension reduction. For drill down or roll down is a reverse of the roll up, and basically from higher level summary to lower level summary or detailed data. And then we can do the slice and dice, so we can do the project and select on only the interesting information so we are looking for, as well as the pivot, so that we can reorient the cube and we can see the visualizations 3D series to a 2-dimensional plans. So we can do a lot of different things in these operations, and all of these can be done in a very fast fashion so that the decision makers can sometimes really see those data in the visualization tools so that they can make their decisions. Finally, in terms of a data warehouse that have been created in multiple dimensions, in this case, I want you guys to understand what is this very useful StarNet query methods try to define. So saying that you create one data warehouse and you have multiple dimensions. You have shipping method as one dimension, customer order as another dimension, customer as another dimension, product, organization, promotion, location, and time. So you're basically creating 1, 2, 3, 4, 5, 6, 7, and 8 dimensions in this data warehouse. And when you try to retrieve the data, you don't really need to always using all 8 dimensions. In this case, the picture shows over here is indicating that I use 5 dimensions only. I focus on customer orders, product, organization, country, and time. So there are 3 dimensions that I didn't use. And you can see that it's very smartly marked out each dimension, what is the level of hierarchy it can be. And now, while we try to draw the pictures like this, it clearly indicates that this data cube that we are looking at using 5 dimensions. And for customer, it use the contracts dimension. For product, it use the product group. And for organization, it has using the district. And for location-wise, it use the country. And for the time, it look into the quarterly information. So this picture, this StarNet query model gives a very clear understanding of what is this data cube looking at, so that you can drop the dimension, you can change the dimension locations so that representing the drill down or roll up, and you can do a lot of different things over here by selecting your representations here. So this is a great tool for you to navigate inside of the data warehouse. So once we look into the technical part of the data warehouse, finally we want to see the architecture. How do we build up a data warehouse, and what is a data warehouse looks like when it's starting from scratch or starting from certain point. So the last topic we want to look into is the data warehouse architecture. So this is the multi-tiered architecture it is supposed to look like. Starting from the data source, you need to have the different sources, you have the database. It can also possibly coming from another data warehouse that you want to pick part of the information and forming another data warehouse. So once those things is been defined, you want to extract, transform, load, refresh all the data. Make sure the data comes to the data warehouse are clean and they have done all the pre-processing steps. So once we have done that, we can monitor and integrator the information, communicate with the metadata. So those code that we wrote is considered as the metadata for the data warehouse, and we can easily form different data marts available over here once we have the data warehouse. And of course, the data warehouse need to communicate with the OIL AP server so that they can provide the front-end users to visualize the data or retrieve the data or whatever queries they are necessary. So this is like the whole structure of the data warehouse in terms of the multi-tiered architecture. So 3 data warehouse models. It can be an enterprise data warehouse, collect all the information about subjects spanning the entire organization. It can also possibly be focusing on some smaller data marts like we see in the previous slide. So it can be a smaller data marts that you are interested in, or for like us, if we are data analysts, we can probably see one of the data marts. Sometimes it's probably not realistic for the whole data that's be available for all the computer science people. So there are some secrets all the time. So it can be grant you the access to the data marts. So it's a subset of the corporate-wide data that is of value to a specific group of users. Its scopes is very well defined, and then it can provide the source of the data for data mining to get the information that you are tasked of. It can also have a virtual warehouse as a set of view over operational database. Only some of the possible summary views may be materialized. So this is instead of building a real data warehouse, it's kind of retrieving the information from operational database. Of course, this is like a cheaper way of building the data warehouse. And therefore, you can see that this is what we call data warehouse development as a recommended approach. So saying that we really don't have a data warehouse and we want to form a data warehouse, what we can do is that it can define a high-level corporate data model, and then at the time we can have some enterprise data warehouse that's available. We may already have some data marts. So we want to combine the data marts together, because the data stores in the data mart are usually being well-defined and cleaned already. So what we can do is that we can collect those data marts combined with the enterprise data warehouse to form a multi-tier data warehouse, which will be able to even provide more information in terms of the whole data warehouse. So finally, metadata. Metadata, as we know, is a very important information. No matter it's in database as well as in data warehouse, it will store a lot of important information. Whenever data warehouse need to be accessed, the information stored in the metadata need to be accessed. So metadata need to talk about the description of the structure of the data warehouse. So what is the code, schema, view, dimensions, hierarchies, what are the things has been defined in the data warehouse. You also need to look into the operational metadata, including the data lineage, history of migrate data and transform paths, how do they clean the data, how do they integrate the data, currency of the data, monitoring information, etc., including the error reports, audit trails, warehouse usage statistics. You will want to know who accessed what and what is the time as well as the size of the data has been accessed by which user. The algorithm used for summarization, so how do you summarize all the information? We need to be able to trace back, saying that if we have new data wants to come in, we need to use the same algorithm to do the same thing. The mapping from operational environment to the data warehouse, the data related to system performance, including the warehouse schema, view, and derived data definitions. So now we probably don't always store some information. We can derive the information. So how do we derive those data need to be stored in the metadata as well. Finally, business data, including business terms, definitions, ownership of the data, charging policies, etc. So all of those things are pretty important in terms of the metadata. The data warehouse usage has three major applications. The first one is information processing, so that you can do the support query, basic statistic analysis, and reporting using cross tables, cross tabs, charts, and graphs, so that they can provide those functionalities for the people who is managers and can see those reports quickly. It can also do some analytical processing. So multi-dimensional analysis of the data warehouse data, support basic OLAP operations, slice, dice, drill, pivoting, those kind of operations. And of course, you need to know how to use those and when to use those for the analytical process. And finally, which is the most important to us, is that it can be also a great tool to provide the data source for our data mining operation. So data mining is what it leads to in terms of a data warehouse. What we want to do in data mining is knowledge discovery from hidden patterns. And you can support association rules, construction and analytical models, performing classification, prediction, regression, and present the mining results using visualization tools. So this is a perfect leading point from data warehouse to our data mining. In our next video, we will start looking into different data mining algorithms.